Hello there. Welcome to my channel. Today, we're going to learn about basic electronics. We will learn what is electricity, what is a battery, what are wires, what is a switch, what is a light bulb, and what is a circuit. All these things are very important in electronics. In our daily lives, everything is dependent on electricity, whether it's your television, your toys, or even a robot. Everything runs because of electricity. And all of these things have basic electronic parts inside of them that help them to run. So if you want to understand how these things work, then this video is perfect for you. Let's get started. First, we'll learn what is electricity. You cannot see electricity, but you can see what it does. Have a look at these cartoon images of lightning. That's electricity. That's how electricity looks like. Actually, electricity is the flow of tiny things called electrons. These electrons are so small that you can't even see them. They're like little balls that carry energy. This energy comes from a battery. You must be familiar with batteries. They come in many shapes and sizes. The energy inside the battery flows out through a wire. This wire connects the battery to something else like a toy car or a light bulb. So electricity is basically the flow of tiny balls called electrons from a battery through a wire to a gadget, which makes it work. Next, let's learn what is a battery. A battery is like a box full of stored energy. Have a look at this toy car. It doesn't have any engine or fuel. All it needs is a battery. The battery is like a fuel tank for this car. It has energy inside of it. And when you connect the battery to the car, the energy flows out from the battery into the car and starts moving. This is how the battery makes the car go. So batteries are like little boxes that contain energy. Now let's learn what are wires. Wires are like roads. They allow electricity to travel through them. In this example, we have a battery and a toy car, but these two parts are not connected. So the battery cannot make the car move. Now if we take a wire and connect both these parts together, then the electricity can flow from the battery to the car and the car can start moving. This is how wires help to connect different parts and allow electricity to flow through them. Without wires, electricity would not be able to reach the parts that need it. Next, let's learn about a switch. A switch is like a gate. It allows electricity to flow through only when it is closed. In this example, we have a battery connected to a light bulb with the help of a wire, but the light bulb is not turned on. Why? Because there is another part in between, which is this switch. The switch is open, so electricity cannot flow through it, so the light bulb is not turned on. But if we close the switch, then the electricity can flow through it and the light bulb turns on. So a switch allows electricity to flow through only when it is closed. When the switch is open, no electricity can flow through it. Next, let's learn about a light bulb. A light bulb is like a magic box. When we connect it to electricity, it turns on and gives us light. In this example, we have a battery connected to a light bulb with the help of a wire. When we connect the battery to the light bulb starts glowing. This is how a light bulb turns electricity into light. Light bulbs are used everywhere to give us light, whether it's your house, your school, or even a street lamp outside your house. They all use light bulbs to give us light. Now we know about batteries, wires, switches, and light bulbs. Let's learn how they work together. When we connect all these things together, we make something called a circuit. A circuit is like a path that allows electricity to flow through it. In this example, we have connected a battery, a wire, a switch, and a light bulb together. So now electricity can flow through this path easily. First, electricity comes out from the positive side of the battery. Then it travels through the wire. After that, it passes through the switch. Then it passes through the wire again and finally it reaches the light bulb. After that, the electricity completes its path and comes back to the negative side of the battery. So this is how electricity flows in a circuit. And when the path is complete, electricity can flow easily and the light bulb turns on. But if we break the path at any point, then the light bulb will go off. So now you know how to make a very simple circuit. You can make this circuit yourself at home and see how a battery, wires, a switch, and a light bulb work together to make a circuit. You can do this by getting an electronics kit for kids. These kits come with all the materials that you will need to make circuits. With the help of these kits, you can make many cool circuits and learn about electronics. You can make cars that run on their own, robots that move around, or even lights that change colors. There are many kits available that are safe for kids. These kits allow kids to experiment with electricity and learn about circuits in a fun and safe way. The best thing about these kits is that they make learning about electronics very easy and fun. With the help of these kits, you won't even realize that you're learning. Making circuits can be a very rewarding experience. Once you learn how to make a simple circuit, you can go on to make more complex circuits. And as you make more circuits, you will learn more about electronics. Who knows? Maybe one day you will become an electrical engineer or invent some new gadgets. And that's it. Now you know the basics of electricity. You know what is electricity, what is a battery, what is a wire, what is a switch, and what is a light bulb. And you also learned how all these things work together to make a circuit. Learning about circuits is the first step towards learning about electronics. If you want to learn more about electronics, then this was a very important video for you. Make sure you remember everything that you learned in this video. And that's all for today. I hope you enjoyed this video. If you did, then please hit the like button. Also share this video with your friends. And if you haven't subscribed yet, then what are you waiting for? Click on the subscribe button so that you never miss out on any of our awesome videos. Thank you for watching. See you soon in the next video. Now let's check how much you have learned in this video. Question number 1. What is electricity? Electricity is the flow of tiny things called electrons. These electrons carry energy. Question number 2. What is a battery? A battery is like a box that contains energy. This energy flows out from the battery and makes things work. Question number 3. What are wires? Wires are like roads. They allow electricity to travel through them. Question number 4. What is a switch? A switch is like a gate. It allows electricity to flow through only when it is closed. When it's open, no electricity can flow through it. Question number 5. What is a light bulb? A light bulb is like a magic box. It turns electricity into light. Question number 6. What is a circuit? A circuit is like a path that allows electricity to flow through it. And that's all for the quiz. If you got all the answers right, then congratulations. You have learned everything in this video. Give yourself a nice pat on the back. And if you got some answers wrong, don't be sad. Keep learning and practicing and you will get better at it. And that's all for today's lesson. I hope you enjoyed it and learned something new. Remember, you can try making circuits at home with a safe electronics kit for kids. And if you want to learn more about electronics, stay tuned for more videos. Thank you for watching and I'll see you soon in the next video. Bye. Bye. Hey guys, hey there. Today's lesson is brought to you by our community. Your support makes these videos possible. So get ready to dive into the world of electricity, because today we're learning about active components. These electrical superheroes use electricity to do amazing things, like turning lights on and off, making phone calls, and even helping robots think. Let's meet them. Hey kids, welcome to my channel. First, let's watch this cool cartoon. Then we'll learn about each component and how it helps us control electricity. Ready, set, go. Alright, let's start with the diode. Did you know that electricity has a superpower? It loves to flow from positive to negative. It's always on the move, zooming through wires and making all our electronics work. But sometimes we need to help guide that electricity in the right direction. That's where the diode comes in. It's like a one-way street for electricity. Look, electricity is trying to go back the other way, but the diode blocks its path, so it can only flow forward. A diode is like a traffic cop directing traffic, but for tiny electrons. Without diodes, our circuits might get confused and electricity could flow the wrong way. And we don't want that. Now let's try again. See, now electricity flows the right way thanks to the diode. Diodes keep our circuits safe and help us control where electricity goes. That's pretty super. Okay, now let's meet the LED. Have you ever seen a nightlight or traffic signal? They use a special kind of diode called an LED. It's like a regular diode, but it does something extra. When electricity flows through it, it glows. Isn't that cool? Yep, this tiny LED lights up. If we take out the battery, the LED stops glowing. The LED needs electricity to shine. In fact, LEDs are everywhere. They're in your toys, TV remotes, and traffic lights. They even light up computer screens. Next time you see a device with a light, say hello to the LED inside. Wow. Now let's meet the transistor. Transistors are like tiny electronic switches or amplifiers. Listen, can you hear me? I'm whispering because the volume is low. If I put a transistor in front of the speaker, it will amplify my whisper so you can hear me better. Or here, if I want to turn the light off, I can flip the switch. Voila! Electricity stops flowing and the light turns off. A transistor lets us control electricity by switching it on or off. We also use transistors in gadgets like computers and phones to boost weak signals and make them stronger. Transistors are small, but they're mighty. Last but not least, let's meet the IC or chip. Have you ever used a calculator, played with a toy, or turned on a computer? You've used an IC chip. Wow. Inside this tiny chip, there are millions of tiny circuit lines. They're like little roads for electricity to flow through. IC chips help us perform complex tasks like adding numbers, playing music, or controlling robots. They're like mini brains that think and solve problems. For example, this toy car has an IC chip that lets it drive and avoid obstacles. That's pretty smart. IC chips are everywhere in devices like phones, cameras, and TVs. They make our lives easier and more fun. Let's recap what we've learned. A diode is like a one-way street for electricity. It lets electricity flow in only one direction. An LED is a diode that glows when electricity passes through it. It's like a tiny flashlight. A transistor is like a switch or an amplifier. It can turn electricity on or off, or make a weak signal stronger. An integrated circuit, or IC chip, contains tiny circuits that perform complex tasks like making phones work or controlling robots. Electricity is all around us. It powers our homes, schools, and workplaces. But did you know that electricity can be dangerous if we don't control it properly? That's why active components are important. They help us use electricity safely and effectively. Hey, do you want to become an electricity pro? There's only one way to find out. Answer these questions and check your answers below. Question number 1. What does an LED do when electricity passes through it? Does it glow, shrink, or pop? Question no. 2. What's the function of a transistor? To switch electricity on or off, make a weak signal stronger, or both? Question no. 3. Which component acts like a tiny electronic switch? Is it a diode, an LED, or a transistor? Question no. 4. What's the function of an IC chip? To perform simple tasks like turning on a light bulb or complex tasks like controlling a robot? Question no. 5. What do you call a component that's like a mini brain? An IC chip or a transistor? If you answered all the questions correctly, congratulations, you're an electricity pro. Give yourself a pat on the back. If you didn't get all the answers right, don't worry. Keep practicing and you'll get there. In our next video, we're going to learn about passive components, resistors, capacitors, and inductors. They're like electricity's best friends. They help control electricity flow and protect our circuits. We use them all the time in our daily lives. That brings us to the end of today's lesson. I hope you had fun learning about active components. If you enjoyed this video, hit the like button and share it with your friends. Don't forget to subscribe so you never miss out on our exciting science and tech adventures. You can also check out our other videos. We have tons of fun stuff to explore. Thanks for watching. See you soon. Hey there, my young engineer friends. Welcome back to my channel. And today I have a treat for you. Get ready to turn into tiny little electrons and zoom through some super exciting circuits. All aboard the electron train. Chuff, chuff. But wait, before we get to the giggles and the glee, let's roll up our sleeves and get serious for just a sec. Today, we're gonna learn about conductors and connectors. That's right, kids. We're talking about the unsung heroes of the electronics world. No, not the batteries, not the switches, but the parts that make the whole thing go round. No, not literally round, just, work. Yeah, those parts. So buckle up, Buttercup, because it's gonna be an electrifying adventure. First stop on our tour is wires. Now, wires are like the roads for electricity. Just like you wouldn't drive your car without roads, electricity can't flow without wires. These little electron highways let electricity travel from one place to another. Now, wires can be different shapes and sizes, just like roads. They can be thick or thin, long or short, but they've all got one thing in common. They help electricity get where it needs to go. Now, if you want to see electricity in action, it's pretty simple. All you need is a wire and a battery. Connect the positive side of the battery to one end of the wire and the negative side to the other end. And voila! You've created a circuit. Electricity will flow through the wire like water through a hose. And if you put a light bulb in the circuit, it will light up. Isn't that neat? You're basically harnessing the power of the electrons, those tiny little particles that carry electric charge. When you complete a circuit, The electrons flow from the negative side of the battery through the wire and back to the positive side. It's like a little game of tag, but with electricity. Hey, speaking of electricity, did you know that your everyday life is filled with examples of conductors? Everything from the toaster to the TV remote to the headphones you listen to music with, they all rely on conductors to deliver that sweet, sweet electricity. So next time you flip on a light switch, take a second to appreciate the role of conductors. They might not be as flashy as a smartphone or as glamorous as a selfie, but they're definitely the unsung heroes of the electronics world. Okay, now that we've covered wires, let's talk about connectors and clips. Now, connectors are like the handshake for wires. They help wires join together so electricity can flow from one wire to another. Now, there are all sorts of connectors out there, just like there are all sorts of ways to say hello. There are connectors that plug in like a puzzle, connectors that twist together like a dance, and connectors that snap together like a turtle's shell. But no matter what they look like, their job is always the same, to help electricity keep flowing. Now, alligator clips are a type of connector, and they're really popular with electronics hobbyists. They're like the social butterflies of the connector world. These little guys can grab onto any wire and make friends with them. This makes it easy to connect and disconnect wires without damaging them. And that means you can experiment with circuits all day long without worrying about breaking anything. Connectors are used everywhere, from your phone charger to your wireless headphones to your robot vacuum cleaner. They help us connect the wires in a way that's easy, safe, and reliable. All right, my tiny electricians, it's time for a quick recap. Remember, wires are like roads for electricity, and connectors and clips are like bridges that connect those roads. Without them, electricity wouldn't be able to get to where it needs to go. Now, isn't that neat? You should also remember that electricity is all around us. Every time you plug in a device or turn on a light, you're using electricity. And thanks to conductors and connectors, we can use electricity to make our lives easier, more fun, and more productive. So next time you see a wire or a plug, remember the little electrons that are zooming through them and the connectors that are helping them along the way. They may be small, but they're definitely superheroes. And that's it for today's lesson, my little geniuses. I hope you learned something new and exciting. Remember, conductors and connectors are the backbone of electronics. So keep exploring, keep experimenting, and keep being awesome. And don't forget to give this video a thumbs up if you liked it. Click the subscribe button to get notified when we upload new videos. Until next time, happy conducting and connecting. Bye.
Hey kids, welcome to my channel. Today we're learning about control components. These are the parts that let us tell electricity when to go and when to stop, just like being the boss of the energy. Now, control components are everywhere in our electronic devices. They help us to operate and interact with the things we use every day. We can use switches to turn our lights on and off, or use a push button to control the volume on our speakers. But how do they work? Let's find out. First up is the switch. A switch is like a gate. When you flip the switch on, the gate opens and electricity flows. Your lights or toys turn on. When you flip it off, the dots stop. It's just like saying to electricity, go or stop. This switch here has two positions, on and off. It's called a double pole switch. Other switches may have 3 or more positions like this one. It has a position for turning on low energy, another for high, and another for turning everything off. Now let's look at the push button. A push button is like a switch, but it only works when you press it. Think about a doorbell. You press it, it rings, and when you let go, it stops. Some toys use push buttons to make sounds or move only while you press. When you press this button, you can hear a buzzer making a funny sound. This sound stops when you release the button. So a switch is like a permanent gate you flip, but a push button is like a temporary one, open only while you press. Switches and push buttons are examples of what we call an electrical circuit. An electrical circuit is a complete path that electricity can follow to do its job. Think of it like a little road for electricity to travel on. The main goal of a circuit is to let electricity flow and power all your favorite things like TVs, computers, and toys. Without a circuit, electricity can't get to where it needs to go and do any work. And when the circuit is broken, that's how we say that electricity isn't flowing and things turn off. That's why all those Christmas lights need to be connected in a loop or series circuit so that electricity can flow from one bulb to another until it gets back to where it started. If even one bulb is disconnected, the whole thing doesn't work. Do you want to try making your own circuits? You can use a battery, wires, a light bulb and a switch to make a simple circuit. Connect the positive side of the battery to one side of the switch, connect the negative side of the battery to the other side of the switch and attach a wire to each side of the light bulb. Then connect the positive wire to the output side of the switch and connect the negative wire to the input side of the switch. Now, when you close the switch, electricity will flow from the positive side of the battery, through the switch, through the light bulb and back to the negative side of the battery. You can even use a push button instead of a switch. Try it out and see if you can make a circuit with these components. Remember, switches turn electricity on or off like a gate, and push buttons let electricity flow only when you press them. And that's our lesson on control components. Next time you turn on the light or ring a doorbell, you'll know the secret behind it. Did you learn something new today? Share with us in the comments below. Don't forget to like, share and subscribe for more fun electronics tutorials. See you next time.
Hey kids, welcome back to our channel, where we learn about electricity in a fun and easy way. Do you want to know how to make your own electric circuits? Today, we're going to learn about the output components. These are the parts that show us what electricity is doing by making light, sound, or movement. Let's check them out. First is the light bulb, also called a lamp or LED. When electricity flows, the bulb shines and gives us light. Big bulbs light up rooms, while small LEDs glow in toys, remotes, or even fairy lights. So bulbs help us see what electricity is doing. Next is the buzzer or speaker. A buzzer makes a buzzing sound like an alarm or doorbell. A speaker makes all kinds of sounds, voices, music, or even funny noises. So buzzers and speakers let us hear what electricity is doing. And now the motor. A motor changes electricity into movement. In a toy car, it makes the wheels turn. In a fan, it makes the blades spin. Even robots use motors to move arms and legs. So motors let us see things move with electricity. Now we can put these three pieces together and make a little robot that moves, makes sounds and lights up. Let's try it out. We'll connect the positive side of the battery to the positive side of the circuit board. And now we'll connect the negative side of the battery to the negative side of the circuit board. Great job. You just made your own little robot. Wow. There are lots of other things we can do with these components. Let's try making a robot face. Let's get started. Connect one side of the buzzer to the positive side of the battery. Now connect the other side of the buzzer to the negative side of the battery. The buzzer should be buzzing. If it isn't, then try flipping it around so that the longer side of the battery is on the positive side of the buzzer. Great. Now let's add some LEDs. Connect one lead of the LED to the positive side of the battery and the other lead of the LED to the negative side of the battery. Now let's add a motor to make the eyes roll. Connect one side of the motor to the positive side of the battery and the other side of the motor to the negative side of the battery. Now, if we turn this switch on, the robot's eyes will spin around and around. Neat trick. But there's still plenty of room inside the robot face for more LEDs, buzzers, motors, switches, batteries, and circuit boards. What else can we make? How about a robot car? Let's get started. Connect one side of the motor to the positive side of the battery. Now connect the other side of the motor to the negative side of the battery. Turn on the switch and the car will zoom forward. Let's add some lights to the front and the back of the car. Connect one side of the LED to the positive side of the battery. Now connect the other side of the LED to the negative side of the battery. And here's the back of the car. Connect one side of the LED to the positive side of the battery. Now connect the other side of the LED to the negative side of the battery. Now if we turn on the switch, the car will zoom forward with its headlights and taillights on. Cool, but there's still plenty of room inside the car for more motors, LEDs, switches, batteries, and circuit boards. What else can we make? How about a robot dog? Let's get started. Connect one side of the motor to the positive side of the battery. Now connect the other side of the motor to the negative side of the battery. Turn on the switch and the dog's tail wags back and forth. Let's add some LEDs for eyes. Connect one side of the LED to the positive side of the battery. Now connect the other side of the LED to the negative side of the battery. Now if we turn on the switch, the robot dog's eyes flash as his tail wags back and forth. Neat trick. But there's still plenty of room inside the robot dog for more motors, LEDs, switches, batteries, and circuit boards. What else can we make? How about a robot arm? Let's get started. Connect one side of the motor to the positive side of the battery. Now connect the other side of the motor to the negative side of the battery. Turn on the switch and the arm lifts up and down. Let's add some LEDs for eyes. Connect one side of the LED to the positive side of the battery. Now connect the other side of the LED to the negative side of the battery. Now if we turn on the switch, the robot arm's eyes flash as it lifts up and down. Neat trick. But there's still plenty of room inside the robot arm for more motors, LEDs, switches, batteries, and circuit boards. What else can we make? You could even attach a motor to the end of the arm to make a robotic hand that could grab things. Kids will love using these kits to build their own robots that make sounds, move, and light up. If you enjoyed this video, don't forget to give it a big thumbs up. And if you haven't done so already, subscribe to our channel so you never miss out on any of our fun science experiments. Thanks for watching, and we'll see you next time.
Hello kids, today we'll meet some very special helpers in electronics called passive components. They don't make light or sound, but they control, store, and guide electricity. Let's learn about them. First is the resistor. A resistor is like a speed bump for electricity. It slows electricity down so it doesn't go too fast. Without resistors, things like bulbs could burn out. So, resistors keep everything safe and steady. Next is the capacitor. A capacitor is like a tiny bucket. It stores small amounts of electricity for later. Then it releases the energy when needed, like giving a quick burst of power to a camera flash. So capacitors are like little batteries that charge and discharge quickly. And finally, the inductor, also called a coil. An inductor stores energy in a magnetic field. When electricity flows through it, a magnetic field forms around the coil. Inductors are used in radios, chargers, and even transformers. So inductors are like magnets made by electricity. Now let's have a quick recap. Resistor slows electricity, capacitor stores and releases energy, and an inductor stores energy in a magnetic field. Now let's look at each one in detail. Here is the resistor. A resistor is a special electronic component that limits or resists the flow of electrical current. Imagine a highway with a lot of cars. If there's no traffic light or any signs to control the speed, the cars might crash. That's like electricity without a resistor. Too much current can damage parts of the circuit. So resistors are like traffic lights and speed limit signs for electricity. They keep everything safe and working properly. Let's see how it works. This is a simple circuit with a battery, a light bulb, and a switch. But we need to add a resistor to protect the bulb. Here's the resistor. We put it in series with the light bulb. Now when we turn on the switch, electricity flows from the positive side of the battery through the circuit. It flows through the resistor first. The resistor slows the electricity down and makes sure it's not too strong. Then the electricity reaches the light bulb. It makes the bulb glow nice and bright, but not too bright to burn out. And finally, the electricity goes back to the negative side of the battery. The whole circuit is a path for electricity to flow from positive to negative. And the resistor helps keep everything safe and working well. Resistors come in different values, which means they slow down electricity by different amounts. Some resistors slow it down a little, while others slow it down a lot. We choose the right resistor for the job based on how much current we need. For example, if we want a really bright light, we use a resistor that slows down less current. But if we want to protect something that needs less current, like a small motor, we use a resistor that slows down more current. Resistors have a special symbol in circuit diagrams. It looks like a pointy line with a zigzag. The zigzag shows that it's slowing down the electricity. Let's move on to the next passive component, the capacitor. A capacitor is like a little bucket that holds electricity. When electricity flows into the capacitor, it charges up. When electricity flows out, it discharges. It is like filling up the bucket when electricity goes in and using the water when electricity comes out. Here's how it works. A capacitor has two plates separated by an insulator. When electricity goes in, it builds up on one plate like water filling up the bucket. This builds up a difference in electrical charge between the plates. It's like the height of the water in the bucket. The more electricity that goes in, the higher the charge and the more energy is stored. When electricity starts flowing out, the charge on the plates decreases. It's like the water level going down. As the charge decreases, the energy stored in the capacitor is released. Capacitors are used for many things like smoothing out the flow of electricity or blocking certain frequencies. They're also used to store a small amount of electricity for a short time. Like when you take a picture with a camera flash, the capacitor releases its stored energy to power the flash. Let's look at the symbol for a capacitor in circuit diagrams. It looks like two parallel lines with a gap in the middle. The gap represents the insulator between the plates of the capacitor. Now let's look at the third passive component, the inductor. An inductor is like a coil of wire that stores electricity as a magnetic field. When electricity flows through the coil, it creates a magnetic field around the coil. The energy is stored in this magnetic field. When the flow of electricity changes, the magnetic field collapses and the energy is released. Here's how it works. This is a coil of wire. When we connect it to a battery, electricity flows through the coil. This creates a magnetic field around the coil. The energy is stored in this magnetic field. If we turn off the electricity, the magnetic field collapses and the energy is released. This is like a spring that's being compressed and then released. Inductors are used for many things like inductors, like capacitors, come in different values. The value of an inductor determines how much energy it can store. Here are some examples of inductors. This is a choke coil used to block high-frequency signals. This is a toroidal inductor used in power supplies. This is RF choke used in radio frequency circuits. Let's look at the symbol for an inductor in circuit diagrams. It looks like a coil of wire. Now let's have a quick recap. Resistor slows electricity, capacitor stores and releases energy. And an inductor stores energy in a magnetic field. These three passive components are important because they help us control, store, and shape electricity. Here's a summary of what we've learned. A resistor is a passive component that slows down electricity. It's like a speed bump for electricity. A capacitor is a passive component that stores electricity like a little bucket. It's like a battery that charges and discharges quickly. An inductor is a passive component that stores electricity as a magnetic field. It's like a spring that stores energy when electricity flows through it. Passive components are important because they help us control, store, and shape electricity. They're used in all kinds of electronic devices to make sure they work safely and efficiently. We hope you enjoyed learning about these important electronic components. Passive components may not be as flashy as microchips or LEDs, but they're just as important in making our electronic devices work. If you like this video, please give it a thumbs up. And don't forget to subscribe for more fun electronics lessons. Thanks for watching. See you next time. Hello friends, welcome to my channel. Let's have a look at the power source. What is a power source? Well, the power source is something which provides the required amount of energy to all our electrical gadgets and toys so that they can work. Without a power source, none of the things will work. Nothing would be there to charge our mobile phones, laptops, and other devices. Nothing would be there to make our toys work. We would not be able to enjoy television or listen to music. This means that the power source is very important for us. Now, there are two types of power sources. 1. Batteries. 2. Adapters. Let's learn more about both the power sources. First, let's talk about batteries. What is a battery? You must be knowing that most of your toys and remote controls work with the help of batteries. The small cylindrical cells that are present inside the toys and remote controls are known as batteries. Here, see. This remote control works with the help of two double-A-sized batteries. If you open this toy car, then you will find 3 double-A batteries inside this car. Also, if you open this flashlight, you will find a double-A battery along with a small switch inside this flashlight. In this way, Most of the toys and some electrical gadgets use batteries as a power source. So, batteries are the power source for many of the toys and gadgets. Now, what is inside a battery? Well, a battery has chemicals that are stored inside it. These chemicals have lots of energy inside them. When these chemicals combine together, they release their energy. This released energy is stored in the form of electricity. This is how a battery works. Now, a battery releases its energy in the form of electricity. This means that a battery is a source of direct current. That's why we say that a battery is a power source of DC supply. Now, have a look at this circuit. It includes a battery, two connecting wires, and a small bulb. Let's make a connection by joining the ends of the wires to the battery. See, now the bulb glows. Why does the bulb glow? Let's understand. When the wires are connected to the battery, then the chemicals inside the battery release their energy. This energy flows through the wires. When this flow of energy reaches the bulb, then the filament of the bulb glows. That's how the bulb lights up. In this way, a battery provides the energy which is required to make the bulb work. So, basically, a battery powers the bulb. Now, have a look at this battery again. Do you think this battery will continue to shine the light forever? No, of course not. A battery loses its energy after some time. Yes, batteries lose their energy. That's why we need to replace the batteries whenever they lose all their energy. In this way, a battery works as a power source for many of our electrical gadgets and toys. Now, let's move to the second type of power source. Second, adapters. There are some devices such as laptops, smartphones, gaming consoles, etc. They require a huge amount of energy to work. Can a battery power these devices? Of course not. For these devices, we use adapters as a power source. The device which takes electricity from the wall outlet and provides it to the device is called a power supply or adapter. Have a look at these power supply cords. All these power supply cords have a 3-pin connector at one end and a connector which connects to the device at the other end. Some adapters come with a wall plug while some others directly fit into the power source. Have a look at these adapters. The first adapter has a 3-pin plug. This means that this adapter gets its power from the wall socket. The next adapter fits into the power source. This adapter doesn't need a wall plug. Now, this adapter will get its electricity from the power source. This adapter will get its electricity from the power source. Let's understand how a power supply works. See, this power supply is connected to a laptop. The other end of the power supply cord is connected to the wall plug. When we plug in the power supply cord into the wall socket, then electricity from the wall flows into the power adapter. This electricity goes inside the adapter and then it comes out from the other end. This end is connected to the laptop. So, the electricity flows from the wall into the laptop. In this way, a power supply takes electricity from the wall and provides it to the laptop. Similarly, we connect the power supply cord of the mobile phone to the wall plug. Then we plug in the cord into the wall socket. As soon as the electricity starts flowing from the wall, it flows into the power adapter. From here, the electricity goes inside the adapter and then it comes out. This electricity powers the phone. In this way, the power supply takes electricity from the wall and provides it to the phone. Now, why do we use adapters instead of batteries for larger devices such as computers, televisions, and gaming consoles? The answer is simple. Batteries cannot provide a large amount of electricity. On the other hand, a wall outlet provides a large amount of electricity. That's why we use adapters which get power from the wall outlet for larger devices. So, adapters take power from the wall outlet and provide it to the devices. Now, there are different types of adapters such as laptop adapter, phone adapter, television adapter, etc. Each device requires a specific type of adapter. For example, a laptop requires a laptop adapter. You cannot use the same adapter to power a laptop and a phone. Now, let's understand what happens when we connect an adapter to a wall socket. When we plug in an adapter to a wall socket, then the electricity from the wall flows into the adapter. From here, the electricity goes inside the adapter and then it comes out from the other end. Now, if the device is not connected to the adapter, then where does the electricity go? Yes, you guessed it right. When the device is not connected to the adapter, then the electricity flows back into the wall socket. In this way, the electricity flows into the wall socket and comes out. In this way, the electricity from the wall socket flows into the adapter and then goes back into the wall socket. In this way, the electricity keeps on flowing into the adapter and then back into the wall socket. Do you think this will damage the adapter or the wall socket? No, this won't happen. The adapter has a special mechanism inside it which does not allow the electricity to flow back into the adapter. Now, let's look at both the power sources once again. First, batteries. We have already learned that batteries store electricity inside them. This means that they have stored energy. Batteries are portable. We can carry them from one place to another and we can power our favorite toys and gadgets with the help of batteries. You must be knowing that you can use batteries to power your remote control. You can also use batteries to power your flashlight, toy cars, and other similar devices. Second, adapters. Unlike batteries, adapters don't store any energy. The function of an adapter is to take electricity from the wall outlet and provide it to the device. Adapters are not portable. We cannot carry them from one place to another. We need to plug in the adapters to a wall socket to get electricity from the wall. With the help of an adapter, we can power our computers, televisions, gaming consoles, and other similar devices. In this way, both the batteries and adapters serve as a power source. But remember, batteries store energy while adapters don't store energy. Batteries are portable while adapters are not portable. Both the power sources are very important for us. We use batteries to power our small gadgets and toys while we use adapters to power our large gadgets and devices. Now, if you want to watch videos related to electricity, then click on this video. And if you want to watch videos related to circuits, then click on this video. Thank you. Hello friends, welcome to my channel. If you want to become a super genius and score good marks in the exam, then definitely subscribe to this channel. And don't forget to hit the bell icon. Hey kids, welcome back to the channel where electronics is made easy and fun. Today, we're going to learn about measurement tools in electronics. These are special gadgets that help us see, test, and build circuits safely. Let's check them out. First is the multimeter. A multimeter is like a super detective for electricity. It has three main uses. First, it can measure voltage. That's how strong the electricity is. Second, it can measure current. That's how fast electricity is flowing. And third, it can measure resistance. That's how hard it is for electricity to flow. We use it to check batteries, wires, or circuits to make sure everything is safe and working properly. When the multimeter is used correctly, the electricity flows safely through it, and we can see the numbers on the screen. Remember kids, always ask an adult for help when using a multimeter because it measures electricity. Now let's meet the breadboard. The breadboard is like a playground for circuits. It's a plastic board with lots of holes in it. We can plug in wires, light bulbs, LEDs, resistors, and other electronic parts without using any solder. This makes it super easy to try new circuits, experiment, and learn. Just like when you go to the playground and slide down the slide again and again, but with circuits, we can plug and unplug things as much as we want to learn and improve our circuits. Many kids and engineers use breadboards to make fun projects like flashing LEDs or tiny robots. Let's have a look at this example circuit. Here we have a battery connected to a light bulb. The positive side of the battery is connected to the long side of the breadboard, and the negative side is connected to the short side. When we do this, we complete a circuit, and the light bulb lights up. Isn't that cool? Now let's summarize what we've learned. Multimeter is a tool that measures voltage, current, and resistance. Breadboard is a tool that lets us build circuits safely without soldering. Both of these tools are very useful for electronics. Let's have a look at both of them again. So remember, multimeter gives detective tool to measure voltage, current, and resistance. Breadboard gives safe playground to build circuits without soldering. Together, they help us test and create electronics safely. Now you know all about the multimeter and the breadboard. You can use these tools to measure and build circuits safely. Don't forget to like, share, and subscribe for more fun electronics lessons. Let's have a look at what you can do with the multimeter and the breadboard. If you want to be an electronics engineer one day, you need to measure things. With a multimeter, you can measure voltage, current, and resistance. With this knowledge, you can make sure your circuits are safe and working properly. You can also use a breadboard to build circuits without soldering. This is perfect for experimenting and learning about electronics. Kids and engineers use breadboards to make fun projects like alarm systems, robots, and more. Multimeter and breadboard are very useful tools for electronics. They help us test and create electronics safely. Now you know how to measure and build circuits safely. Don't forget to like, share, and subscribe for more fun electronics lessons. Bye-bye.